Okay, so this video is over orbital notations. The information you must know in order to draw the orbital notations of elements is that the arrows, either the up arrow or the down arrow, represent electrons. The sublevels are S, P, D, F. S has 1 orbital, P has 3 orbitals, D has 5, and F has 7. So those are the paths the electrons are going to be following. So in order not to have to draw these pictures, you just draw a line over the S, because since it has 1 orbital, it has 1 line. P has 3. So those 3 lines are representing these 1, 2, 3 paths there that the electrons can be found in, or orbitals. D has 5, and then there's 7 different patterns for F that I didn't want to try to draw. Okay, so the number in front of the sublevel that you'll see tells you what energy level the electrons are going to be placed in. And then each one of the orbitals can hold up to 2 electrons. So for a P sublevel, they can hold a total of 2, 4, 6 electrons. Pauli's exclusion principle tells us that we want to put an arrow up and then an arrow down, which represents the spin of the electrons, the different spins, so that they can be in the same area. Let's see, in Hund's rule states that if you have more than 1 orbital, there should be a positive spinning electron in each one of those orbitals before you start pairing down. So for instance, with these 3, before you pair down, you have to have 1 up electron. Okay, so let's do some practice on these. Alright, so let's start with fluorine. Fluorine, if you look on the periodic table, has 9 for the atomic number, which means it has 9 protons and 9 electrons. So we need to draw 9 electrons for fluorine. So we're going to use Aufbau's chart here. And Aufbau principle states that the electrons are going to fill in the energy level and sublevel with the least amount of energy first before they fill in the higher energy sublevels. So you're always going to be starting up here for every element. And you're just going to follow this path. So once the first energy level or sublevel we're at is 1s, and once you're finished with that and fill it up with its 2 electrons, then you move to this one. Once you put 2 electrons there, then you follow the path and move to 2p. P has 3 orbitals, so you can have a total of 6 electrons. Once you get those in, then you follow this path. And you just keep going, filling up the electrons as needed, and you stop when you reach the atomic number of that element. Okay, so we're going with 7, move that over here. We need to go with 9 electrons, and I sometimes just write it right there so I know that I'm trying to get 9. So we're going to start with 1s, and since this is an s orbital, I put 1 line above it, not because of the energy level is 1, but because it's an s. And I need both the electrons, so there's my positive, there's my negative. Okay, so that one's finished. So now I follow my path, and it tells me that I need to go to the second energy level, S sublevel. So since it's an S, it gets 1 line. I'm going to put the energy level number there, and I need both of those electrons. So that is filled up. Then I move to P sublevel, which has 3 orbital paths, and this was in the second energy level. And I've got 1, 2, 3, 4 total electrons right now. I'm trying to get to 9. So here's 5, 6, 7, and we're putting 1 up on each line because of Hund's rule. There's 8, and then there is 9. So the second energy level are the electrons with the 2 in front of the sublevel. So we have 7 valence electrons for this one. So if you were to use this to draw a Lewis dot structure, it would be F, and there's your 1 by itself. Okay? This is the orbital notation. All right, let's do another one. I want you to try carbon. Okay, pause the video, try it by yourself, and then come back and check your answer. Okay, time lapse. 1s. I need 6 total, so 1s is done. 2s. Follow that around because that's filled. And then we still need 2 more electrons, so I'm going to draw 2p because that was our next energy level, sublevel. I only need 2 electrons, and even though I just need 2 electrons, you're still going to draw that other orbital there. And again, that's representing those little patterns that electrons are leaving behind. Okay, now the next one I want you to try is iron, and iron on the periodic table has 26 electrons. So pause the video, and I want you to check that one. Okay, so this is what you should have for iron. So iron had 26 electrons, so we filled up the 1s, then the 2s, then the 2p, and then it said go to 3s, and then it said to go to 3p. Fill that up because I needed all those electrons. And then I went to the 4s, and then I finally got to my 26 electron when I got to 3d. So that is the orbital notation of iron. And the 4th energy level here, that 4th energy level right there, that is the valence energy level. So that is the valence energy level. And I know that's the valence energy level because that has the highest energy level. So the 1, 2, 3, 4s that are there are responding to the period numbers 1, 2, 3, 4, 5, 6, 7. So that's what those numbers are standing for, the energy levels that the electrons are going in. Okay, so that was your short clip on orbital notations. There's more information in your book in Chapter 5, Section 3 if you want to read that. Have a great snow day.